Consecutive integers means this. One side's going to be n. One side's going to be n. The next side's going to be n plus 1, and the third side's going to be n plus 2. There's my consecutive integers. Now, if I know I have a triangle, right triangle, actually, by that, right triangle, here's my right triangle. Which side is my longest? N plus 2, right? If I take n and I add 2 to it, it's going to be larger than the other sides, right? So my longest side is always my hypotenuse. So n plus 2, my shorter sides. These don't matter where they go. I'm just going to put them in here, n plus 1 and n. It doesn't matter where they go. I can have n and n plus 1 switched around. It doesn't matter. Now, knowing the Pythagorean theorem, we know that what? A squared plus b squared equals c squared. So we're going to go into this problem and set that up. A squared plus b squared equals c squared. And so I'm going to go into this problem. And here's my, I don't care which one's A and B, so I'm just going to say this is A. So I've got n squared plus equals c squared. N squared plus n plus 1 squared equals n plus 2 squared. Now, working this out. Now, a couple of things. I'm going to write this out is here. N squared means n times n. I'm just going to write it like this. N plus 1 is n plus 1 times n plus 1. Too many people make a mistake when they do that. And this is n plus 2, n plus 2. When I square means I need to FOIL. Not just square the n, not just square the 2. I need to FOIL it out. So if I work this, n times n is n squared. Plus, now if I FOIL this out,
n squared plus 3n plus 1.
I'm going to get n squared. N times n is n squared.
Oh, sorry, 2n.
And it's going to be 2n here. 1 times n is 1n. 1 times n is 1n, so it's going to be 2n plus 1. When I FOIL it out, I'm going to get that. Okay? Equals, over here, if I FOIL this out, I'm going to get n squared plus 4n plus 4. If I FOIL it out, times everything by everything. Now, combining terms, I'm going to combine this side first. So at 2n squared plus 2n plus 1 Now to solve any equation down, here's the deal. To solve anything down, I have to get it equal to 0. Zero product property. Back to that zero product property. Can't solve an equation unless it's equal to 0. So therefore, I'm going to move everything over to one side. So I'm going to get rid of this stuff. So I'm going to subtract n squared off both sides. I'm going to subtract 4n off both sides. I'm going to subtract 4 off both sides. This side all cancels off, and I'm going to get 0 equals. Now on this side, 2n squared minus n squared. N squared. 2n minus 4n. Negative 2n. 1 minus 4. Minus 3. And now I have it equal to 0. How can I solve an equation once it's equal to 0?
You can tee this one out.
Tee it up, quadratic formula, complete the square, which I hope you don't use. But I would probably tee this one up. This one tees up very nicely. I have n and n. And I have a negative 3 and a positive 1, positive 3 and a negative 1. Now I want a negative 2 in the middle, which would probably be a good one for this one. Negative 2 in the middle, so I got n and n. Minus 3 and a positive 1, I think will give me my middle term. Correct? Now if I set each one of these equal to 0, what's n minus 3 equals 0? What minus 3 is 0?
3.
One of my answers is gonna be 3. N plus 1 is 0.
-1.
-1. I have two answers. N equals 3, N equals 1. Anyway, now if I go back to my original setup, way at the beginning. If N is 3, what's 3 plus 1? And 3 plus 2. So what are my sides of my triangle? 3, 4, 5. Now they did give us another answer. They said N is a -1. -1 plus 1 is?
0.
And -1 plus 2 is?
We can't do that while we
-1 can't be dimension, 0 can't be dimension, really. So that one's not going to work, but I want you to understand that there is another answer here. You know, down the line, in certain types of geometry, that will work. I want you to understand how we can get that answer. But right now, we're going to cross it off because the geometry we're using, we can't have it. Setting up. Now, think about that problem. Okay, exponents. Multiplying binomials together, right? Monomials together. Foiling. Bringing everything over to one side, adding, subtracting polynomials, right? Teeing it up. Pythagorean theorem. Correct? Solving down and checking your answer. 8 concepts that we talked about so far this year. 8 concepts that we talked about, not just in one chapter, but all through what we talked about in one problem. That's kind of when I talked about it, says knowing your steps, knowing how to use this stuff, we're going to apply all this together at once. And using all the methods as we go through. Okay. Question on that one? Does that make sense? I have 2 formulas I want to cover today. I should have done them before. The first one is the distance formula. I'll give you to it, then we're going to talk about it a little bit here. How about the distance formula? What we have here, the distance is equal to, I think you dealt with this one, x2 minus x1.
Yeah, we did this a lot.
I think usually Mrs. Osmond covers that one quite a bit, doesn't she?
Yeah.
You did the distance formula. And the other one is the midpoint formula. Midpoint x2 plus x1 divided by 2. y2 plus y1 divided by 2. Okay? Your middles? Yeah. Now I got a question for you. Now I want you to where does the distance formula come from?
Graphing.
It's graphing, but there's something else. Distance formula. How did they develop the distance formula? Okay. I'm going to give you 2 points. Plot those 2 points on a graph. Just draw me a sketch, plot those 2 points. Come on. You should be able to plot those, right? X, Y. Okay. First point, you have a -3, 4. I'm going to call that point T. Second point is 5, -2. I'm going to call that point R. Okay. So really, when we do the distance formula, we're finding the distance between those 2 points. Okay? Like Gavin said, graph it, right? Graph the distance between them. Where did the distance formula? Now, if I went like this, I'll change the color here. What kind of shape do I have? What have we been dealing with yesterday? Right triangle, Pythagorean theorem. Pythagorean theorem is where the,
Is it like the rise of the
I think the rise of a run
and
is
then
the square.
hypotenuse?
That's the square of the high rise of a run. So really, when we look at the formula here, it says take y2 minus y1, right? The difference in my y coordinates and square it, right? Take the difference in my x coordinates and square it, right? And then take the square root of it. Really, what this formula is, okay, here's negative, here's a positive 4, here's a negative 2, this side's 6, this side's negative 3 and a positive 5, this side's 8. It's a squared plus b squared equals square root. That's what the distance formula is. Distance formula is a squared plus b squared equals c squared. That's it. And so it's not a lot different than what we've been doing, but what they said is, what they're coming up with is a formula that says, I don't want you drawing everything out all the time. Here's the formula. No. Let's solve it that way. And so what they want you to do is say, okay, the distance between these 2 points is equal to the square root of, taking my x coordinates and subtract them, so 5 minus a minus 3 squared plus, take my x coordinates, or y coordinates, negative 2 minus 4 squared.
It doesn't really matter what way you put them though, right?
Okay, that's good. Does it matter which way I put it? Do I pick the second point or the first point? Does it matter?
No.
Do I have to be consistent?
Yeah.
I'll think back to slope. When I did slope, did I have to be consistent? Where if I picked y2 over here, I had to stay with y2, right? I don't have to be consistent doing this. Don't have to. Why?
Because if like you go negative 2 minus 4, that's negative 6, and then if you square a negative number, it'll be positive.
No matter if I do it one way or the other, it's squared. It's always going to be positive. It doesn't matter. The consistency is not as important on this one. It is important on slope, but this form it doesn't matter. So let's finish this problem up. The distance between these 2 points, 5 minus a minus 3. 2 days make a?
Wait, shouldn't it be plus a negative 3?
No, distance form is minus. X2 minus x1. X2 minus x1. So we're going to go minus. So 5 minus a minus 3 is 2 negatives make a?
Positive 8.
Positive. So we're going to get 8 squared. Negative 2 minus 4.
Negative 6.
Negative 6 squared. I'm going to put that in parentheses and add them together. Now, a lot of people like to do this when they do the distance formula, and I want to point this out. The distance formula, the square root, right here, that square root is like a parentheses. Okay? You follow me? What I mean by that is this. You have to do everything underneath there first before you take the square root. A lot of people like to say, well, I got a square root of 8 and I got a square root of negative 6, and these squares, they're just going to cancel off, so I'm going to get 8 plus a negative 6. Can't do it. It's like a parentheses. The square root's like a parentheses. Do underneath first. So in other words, distance is equal to the square root. 8 squared
64.
plus negative 6 squared.
36.
And if I add those together, I get the square root of 100, which is 10. So my side over here, the length between those two sides are 10. That's pretty good by just guessing numbers to get a point to be exact. I just picked numbers out. Questions on that?
So then to check, you can do
Yes.
rise over run.
Yeah.
Both squared equals.
Yep. Rise over run both squared equals that. Now midpoint. What does midpoint find? Midpoint finds the middle point. So if I had these 2 points, let's say this point right here, and this point right here, correct? And I said, find me the middle point, right inside there. Middle, I always think of midpoint as average. Okay, so if you look at my midpoint here, my 2 points are right here. What I'm going to do for my midpoint formula is I'm going to add the x-coordinates together and divide by 2, and add the y-coordinates together and divide by 2. 5 plus a negative 3. 2 divided by 2 is 1. So my midpoint's at 1. 4 plus a negative 2 divided by 2 is 1. So my midpoint's at 1, 1. How's that look? Okay? Here's your distance. Have you dealt with distance and midpoint before?
Yeah.
Okay, now I have a question. I'm going to just take a second to think. Let's talk about midpoint. What kind of word problem would I come up with for midpoint? You think of a word problem for midpoint? Somebody came up last hour, they said this. Let's say on a geographical map, Wheaton's at 0.36 and Dumont's at 0.28, whatever. Where is one person left Dumont, one person left Wheaton, where would they meet? In the middle. Would that work?
Yeah.
That's a midpoint one. I thought this one, I thought was pretty good. I said, the two endpoints of a diameter of a circle are this. What's the center? That work? Where's the center of a circle according to its diameter? Right in the middle, right? Okay. Circle is drawn on a coordinate plane. As shown, I don't have pictures of left. The endpoints of the diameter are -1, 5, and 4, and -3. What is the center of the circle? What is the center of the circle? So if I was drawing this out, I'll draw it out for you. I have this. -1 and 5. I have, so there's my diameter. That's a terrible. That's like a big. But what comes down to? But there's my circle. Okay. Now what? How do I find my center?
That's -1 and 4.
I actually put my point to this is a -1, 5, and this is 4, -3. So if I wanted to find my center, I'm going to midpoint, right? My center is going to be located at 4 plus, take my x-coordinates, add them together, divide by 2, take my y-coordinates, add them together, divide by 2. Okay? So now my center is 4 plus a -1 is 3. Divided by 2 is 1.5. 5 plus a -3 is
2.
2 divided by 2 is
1.
so my midpoint is at 1.51. Okay? Trying to give you a viewpoint of what kind of work problem I'm going to get. Does that work? Okay. How about this question? Find me the radius of this circle. Find me the radius. Think about what you do. Try something. Find me the radius of this circle. Think about what radius is. Find me the radius, the length of this circle. What would you do? Give you a second to think. What you would do. You look at your grades online, you look through all, some of the people you're working. Do you have concerns about your grade? Come and see me. I didn't put an eligibility in yesterday. Simply put, I just went through it. You fail, you fail, and that's pretty much what I did. If you have concerns about your grade, I expect to see you. Or you can go online. If you can't go online, you better come and talk to me. To see what your grade is. And we can talk about different things. To go from there. In my opinion, this is the toughest one. Yeah. The reason being is because we have Thanksgiving break built in, and then you get the flow again, and you think you're gonna have to get caught up, and all of a sudden you have Christmas break, and you take a break, and you come back, and it's only 2 weeks into the quarter, and not enough time to get caught up again. So it's a tough quarter to have, so. How do you find radius?
You're gonna take the,
What's that?
Distance and elevation.
Distance of what?
you could just use the midpoint and an endpoint.
Okay, you could do that too. So with Hannah. Hannah said take the distance between these two and divide it by 2. Would that give me the radius?
Yeah.
Okay. Gavin said take the distance from the midpoint to the end. Would it give you radius? Okay. I would start out with the midpoint one, but that's fine. I'm going to change the question here in a second. So distance equals, let's just use this midpoint. I'm going to use this point here. I'm going to take my x-coordinates, 4 minus 1.5 squared plus -3 minus 1 squared. Okay? And if I take the distance here, 2.5 squared plus -4 squared, that's equal to -4. I'm going to get 6.25 plus 16. I'm going to get the square root of 22.25. Okay? That's one way. Now what I can do is there's 3 ways I can write this question. Just think of ways that you can see a question, because everybody's been saying they're having a hard time with word problems because they don't see it, right? One way I can write this question is this. Find me the radius of the circle. Whatever way you use, right? You got a lot of different ways. Second one I can write down is find me the radius of the circle and justify it with a different measurement. So in other words, find it one way, then use another way to justify your answer, make sure it's right. Third way I can write this answer is find me the radius of the circle 3 different ways. 3 different ways. How can I do it 3 different ways?
You could use the other endpoint.
I can use the other endpoint, that would be the second way, and I can use the distance formula on Canvas, that is the third way, right? They should all come up the same answer. A lot of times when I do that, when I put a question like that on a test, some people say, well, I got this, this, and this, they're all different, but must be right. If you're doing radius, radius is radius. They all better be the same answer. Okay? There's many ways to do this. I want you to start thinking, saying, okay, what am I asking for? I'm looking for the radius of a point from here to here. What am I asking for? There's many ways of doing it. So, questions on that so far? Your assignment is on page 594. You get those done, you can have them all. Hang on, you know who you are. 594. 594, I want you to do 3 through 48 by 3s. 3 through 48 by 3s. You are going to hand in number 30, let's say 33 and 45. When I say you hand it in, what I would like to do is take a picture of it. Okay? I'm going to be very, very quiet. What I've heard is their iPads are not checked out, so I'm just going to kind of leave them in here until somebody says, where are they? So, now I'll play down and they ask me, why don't you have them? But if you need an iPad to take a picture, you can grab one. So.
You don't have to do 20, but how would you do that?
On that same side?
Yeah. No, on like the one that we did.
What?
28, 28.
That's what's good. So the distance between 2 points. Suppose the distance between 2 points on a coordinate oh, it's between those two. Find the points. Okay, what I would do on that one, it's not giving you the exact answer, it says it's between 10 and 13. Okay. So, we don't have, it can't be above, right, above, right? What's this stuff at this point? I'm gonna say one of my points, I don't think it gives any points today. It's probably the easiest point to work with is 1, right?
Let's pick a number between 10 and 13.
11 squared. I think my hypotenuse was 11. What's 11 squared? 121. So what I know now, that is this side squared next to, oh, here, and this side squared would add up. You can add this. 121 might be a little tougher one to work with, right? What, it says between 10 and 13? Well, I'll have to look at it. So what we could do is,
Could we do 10? 10 is, 10 is 100, and
No,
then,
like your time, switch 11 and have
we could do that, right?
you work with 100.
It still doesn't, what I probably would work with is, it says 10 and 13, I don't know if they do that, I probably would use 13. And the reason I use 13 is, 169, right? And I'm, 5, 12 would be two sides that would work very well. It's 25 and 144, okay? And 'cause I'm looking at numbers that would work Pythagorean, otherwise you're gonna get decimals, which isn't bad. You know, and so if I think about this and I go over 5, up 12, then my point would be, it says 52 points, 1 semi-0, 0, 0, 0. Now, there could be a lot of different answers to this. It could be 512, it could be negative 512, it could be 12.5, negative 12.5, you know what I mean? It could be any of those answers, so there's a lot of different answers that work that give you that.
Thank you, Hannah. Yep, that's good too. Well, that way I have got those and these are the other ones, okay?
Yep. I sent you my online thing last night.
Your weekly, oh, yep, I saw that too, your quiz. I did not get your classes correct.
Okay.
I got everybody else's correct, but not yours. I think I'm gonna work on during lunches to get your test corrected during lunch,
Okay.
in-class test. And then I'll go back and do the, I don't know what happened here. I only got, maybe I just sent the response. I got 1, 2, 3, 4, 5, 6. So there were only 6 here yesterday.
For yesterday?
Shayla was gone, Peter was gone, Austin was gone, and Gus was gone. No, wasn't clear.
Gus sent his. He sent it to the whole class.
He sent it to the whole class.
So, like, because I got his, what he sent, I'm like, oh.
That's probably why I didn't get. Yep, there it is.
Yep.
So, okay, sounds good. Thank you.
Yep.